Hello guys, welcome back. In this video, let's create our own retrieval augmented generation RAG bot using the tech that you are seeing on the screen. As I have been explaining in my earlier videos about Unstructured, there are 4 different videos where I have showed you how to do the minor steps related to Unstructured, and now based on the knowledge that we have gained so far, we are going to create a simple RAG applications, and the video will be step-by-step guide. So if you want to follow along with me, the code is already being pushed in GitHub inside this data cleaning, and you can see here there is this called LangChain Groq Unstructured RAG. So just clone this repository locally. I have already cloned here, and now first create a virtual environment and activate it. Go inside this data cleaning folder, and then there is the file, as I said you, this LangChain Groq Unstructured, and open this in VS Code. And now this is what I'm going to explain you in this video. Let's get started. Okay, there is the notebook. You can follow along with me as I said you before also. So what is it going to be used is LangChain for the framework, Unstructured as I have been explaining, and this is the series, and this will be the last video in this particular series for now. Unstructured, that is what we will be used for data cleaning. LangSmith to have the traces, Qdrant Cloud as a vector storage there, and we will be using the Groq's API for fast inference. Llama3 we'll be using from the Groq API, and then we use the Fastembed for embedding. So we'll be using these 3, and I will be showing you how to use the PDF as well as Markdown in order to have these RAG applications. That is the beauty of Unstructured, and that is why I created this series also, because you might have multiple file types and you want to do the pre-processing or data cleaning using one particular library. Let's say you do the pre-process using Unstructured, and the process data that you get out of this Unstructured will be the same, so you can have other extra implementations on top of that. It makes life a lot easier, right? So these are the normal things, and I have provided all the links here. You can just go to this particular link, and again there is also some additional links here, and we can proceed with the setup. So for the setup, I have, as I showed you, I have installed all the necessary packages here. And as you can see here, we have those all packages installed, and this is normal warning control, and I have imported here, but I will show you the import as I proceed in the code also. And just to show what are the different packages versions I have been using, because that was the main concern for many of you, that it is not working properly because there might be the conflict between the packages. Here are the different versions that I am using. You can install these versions if it showing some errors. And before proceeding this also, I have seen in the comment section you have been asking, okay, I cannot install Unstructured because Unstructured under the hood needs some system level packages also being installed. So it seems that many of you are facing that difficulty, and I have already mentioned that in the previous video in this table extraction. I will just show you what I have explained there. If I go up here, I have provided the link, because under the hood Unstructured uses different strategies, and for that strategy it needs to do some as you can see here, optical character recognition or some other different things to extract the information. So it might not work only by installing that in the virtual environment. So I cannot say, okay, install this, because I am working on Mac and it might not work in Windows and Linux. So here is the link where Unstructured has themselves provided the instruction how to install different things, and there is one from the Stack Overflow which I find that works in my machine. So please follow these things, and it differs between the machine, so that's the reason I cannot just provide you the bulletproof idea, okay, install these things. You need to do some explorations by yourself. That's just a disclaimer, or let's say the information there, because it might not work for all of you. And why Unstructured, I have explained that many times, but as you can see here, it supports many file formats. That's the reason we use Unstructured for the data cleaning part, and in this case I will be just focusing on Markdown and PDF, just to make that again clear. First, let's pre-process the PDF, right? I have been explaining already in my previous video, so I'm not going in depth. But if you want to know some documentations or code, what is being implemented in the partition PDF, you can just provide 2 question marks on the last, and it will show you what are the different parameters it is there, and you can use those into your code. As I said you before, again, because in the beginning I showed you with the normal parameters or the arguments, but as we learn new things, we can provide additional parameters already into the partition PDF itself. So you can see here I'm providing the file name as file name. I'm using the GPT for all paper for PDF, and we can say extract images equals to false. If you want, you can pass this to true, so it will be, and you can pass the path of the image and all the images will be extracted. I recommend you to watch my previous image extraction notebook or the video for that. And you have to use the strategy high res, and this high res model name you can use different. I'm using here Yolox, and info table structure equals to true. Chunking strategy by title, this one you can use and you cannot use also, it depends, but I recommend you to use later. That's, I will show you how to do that also, because when you provide this chunking strategy by title, then the extracted informations will be little bit different. I will show you on the higher level what it looks like. And this maximum characters and the combined text under nchar equals to 200 is because when we do the chunking strategy by title, we want to have those documents in one chunk which are less than 200. We don't want that to be in a different chunk, so we want to consolidate that into one chunk of the extracted information, right? When you pass these things, and if you want to see what are the different elements being extracted, you can see there is just composite element and the table chunk. There is just 2 different elements being extracted, and there are 15 of those composite element and just 2 table chunk. This is because we are providing the chunking strategy by title. If you provide that, then it will be showing in these 2 format only. But before, we have seen that we have header, we have title, we have footer, we have image, table, and narrative text, and so on. So it is not shown here, right? That is the reason I'm saying if you use the chunking strategy by title, it will be just in these 2 format here. And you can see there is just table and composite element. But what you can do is you can just not use the chunking strategy by title. You can comment this line, and when you do the same thing, and if you go down, you can see there are different elements now being extracted. Just play around with this, which one you want, because I'm going to use the chunking by title later on when we combine the 2 different PDFs and the markdowns. But it's up to you which steps you want to take. I'm just showing you 2 different things, so you know that okay, when you do the chunking by title, these are the 2 elements being extracted, and when you don't use, let's say, chunking by title already in the partition PDF class, then it will be showing you other different things also. And if you want to just view the elements, you can see PDF element 0 to dictionary, and then you can see this is the text being extracted, and this is the uncategorized text, right? And now if you want to see what is the table content also, I have explained in depth in the extracting table information, but if the category is table, then you can get the table things. You can then have the metadata of that particular table text as HTML, and if you just want to print, you can see that it is extracted in this format, and you can ask the questions related to tables and it will provide you the answer. That's how it works. And here I'm just wanting to exclude the references, because if you extract some PDFs, there will be some references also, so you don't want the references to be reflected in your extracted information in your chatbot. So for that, what you can do is you can see, for example, how many there are in the references. So I am saying here element.text references in the title, and you can see here this is the type is title and the text is references. I don't want to include that. So what we can do is we can get the ID of that, and then you can just first print, okay, what is there, right? You can see the Nomic AI is the first element, and if you go to the data, GPT for all, and if you go to the references part here, you can see this is the first references. So we don't want that to be included in our RAG applications, right? So here you can see this is the first references being extracted, and here what we are doing is filter out elements with the parent ID matching the references ID. So we don't want that to be included. And also filter out the headers. You don't want the headers also. Just play around with this. You might not need other different elements also. Just go here and filter out all those things. All right. So once that is done, now you can have the filtered out PDF elements, and you can see there are 72 PDF elements being extracted from that particular PDF. And if you want to just pick the random 33 one, and you can just see what is the text and what is the type, right? So this is all about the PDF extraction. I have already explained this in the previous video, but also as a reference, this is how you can extract using the PDF. Now I'm not going to go into depth into the Markdown. It will be all the same things. It's just you provide the file name. I'm using this Uber 10Q March 2022 MD file, which is being extracted by the Llama parse. You can watch my Llama parse video also and see how I did this this part. And then I'm just passing in the partition MD this file, then it will be extracted in the similar format of the partition PDF. That's the reason we are using unstructured, right? Just an example. Here you can see this is the MD elements 33 as an example, PDF elements 33 as an example. You can see that there is the type, title, here is also the type, title, element ID, text, here is also text, here is metadata, here is also metadata, file name, file directory, file type, file name, file directory, file type, and if there is additional information, it is also being picked. For example, page 2 and so on. So here in the PDF elements, we also have the page. So it extracts the page informations, but in the Markdown, we don't have those page information. So it is not being extracted. By this way, you can see that we have the similar things. So we can play around with this as our choice. Now let's still do some more exploration. I'm just saying, okay, how many are the PDF elements? 72. How many are the Markdown elements? 1506, because it's quite long document being extracted. So here is the part. Now I said chunk by title, right? Before also you can do it, but then here what I'm doing is chunk by title, and I'm providing the extracted PDF elements and the Markdown elements. So you can play around with the chunk by title arguments also. So here you can see there is 731 in total now. You can just play around with this. So if you just see PDF elements 0, you have 3202 just being extracted, which does not make any sense if you ask some questions related to it, right? But if you go to PDF elements 1, you can see this is also extracted in this format. It does not even make any sense if you ask some questions into your RAG application or chatbot. But what we can do, we did the chunk by title, right? Now what happens is there is the elements 0. If you view that, we can see that many are being extracted in one chunk. So it somehow makes sense. If something is asked in this chunk, then it can provide you the information, right? So you can see when we do the chunk by title also, now this type is converted to composite element. Before, if you go here, it is uncategorized text, it is uncategorized text, right? And now when you combine, it is being gone into composite element, and element ID, text, and all the different metadata is also being included with it. Now we have a little bit more cleaned version of that particular things. So if you want to know what are the different parameters you can provide into the chunk by title, as before, you can have 2 question marks in the notebook, and it will provide you all the different informations, and you can just play around with this. Just as an example, I have shown you here a chunk by title. This is what we used before, but by comma, and you can provide other different things already here, so that you can see you can then decide to make the chunk bigger or smaller with some experiments. Now the next part, we have extracted the Markdowns, we have extracted the PDFs. So what we need to do in the RAG applications, we need to then create a vector database. We need to embed that particular chunk and then pass that into the VectorDB, right? Load the documents into the VectorDB. So for this, I have used the Fastembed embeddings. I have used Qdrant Cloud for that. And here you can see I'm just creating the documents, and I'm passing all those extracted elements into the documents. And if you see here, the length of documents is 731. That is exactly the same number of elements we have extracted, or let's say combined with the PDF elements and Markdown elements. That needs to be the same, because we are converting each of the chunk into the documents, so it must be the same. Once that is done, what we can do now is we need to have the API things now. For example, Qdrant URL and Qdrant API key, because I'm going to use the Qdrant Cloud for that. And one thing, I'll be going off topic here, but I want to show you one thing. You are seeing here too many things being used, Qdrant, Groq, and so on. Just for an example, if you go to my channel here, and if you are confused with something, just go here and search. For example, let's say you want to know something about LangSmith, which I am showing here. So you can just go here and search LangSmith. I have in-depth videos related to those. If you want to know something about Qdrant, then go here and search Qdrant. I have local mode, server mode, Qdrant Cloud being explained here already in depth. So you know the idea from there, and you can just get the API keys. And if you want to go with the Groq also, so here if you just go and search Groq, you can see here is the Groq. I have created rag with the Groq also, so you know how to set up the Groqs. Because if I go all in this video, then it will be quite long video. I hope you understand that. And one thing is also, if you want to get the API keys, as you can see, I'm using the .env, and the API are being stored in the .env, but I cannot show you that because I have other different API keys also. But the same thing is here, example.env. So you can just play around with this, or you can provide your, let's say, API keys here. So that's how it works, right? And now I'm getting here the Qdrant and the Groq API key. Embedding is Fastembed embeddings, and now I'm creating the vector store. So Qdrant.from documents, you can pass the documents that we have. You can pass the embeddings, which we just have it here. URL is the Qdrant URL. Collection name, you can just give some random name. API key is the Qdrant API key. So when we pass this, the vector store is being created, and now we can just do the retriever, vector store at retrieval, and you can say source type is similarity, and the source k arguments equals to 3, meaning that I want to have the top k 3 out of that vector store. So that is the vector store knowledge base being created. Now to the RAG part now, right? So to creating the RAG, I'm using, as I said, Qdrant, Groq, LangChain, and Llama3 via Groq API. So this is the normal importing things here. So you can write the template here. You are an AI assistant, something, something, something. You can be precisely providing the template, and there is the question, there is the context, and you can pass the prompt into the prompt template. Template is template, and the input variables are the question and the context. Now once that is done, we need to have the LLM. So that is chat Groq and temperature 0. You can play around with this. Model name is, I'm using the Llama3 8B8192. So you can choose different models. So how to choose the different models? Just as an example for you. So this is the Groq Cloud. From here you can create the API. But if you go here, there are different models that you can choose. So I'm using this Llama3, but there is Mixtral also, there is Llama3 8B also, there is Gemma 7B IT. You can just choose one of the model from here. So here I'm using Llama3 8B 8192, and you can see here docchain is load QA with source, and I'm passing LLM and the map reduce. You can play around with this also. And the question chain, generator chain, I am using the LLM chain for now, and then I'm passing the prompt as well as the LLM. And the QA chain, this is the normal things that you need to provide, and these things might change over time because LangChain documentation is also changing over time. So you might be getting some deprecation issues, error messages, or it might not work in the future at some point. What you need to do is go to the latest LangChain documentation, and maybe you need to replace some of those parameters, because I have been seeing this a lot of questions in the comment section. Okay, this is not working. Why? Because this is new field, LLM is new field. There are different packages coming along. There is different versions. Sometimes each month there is new version, so it will be quite challenging, and not all the parameters or arguments work into the class. So you need to somehow do your research also based on the existing code. Please do that if it is not working. If it works, then that's fine, right? Once that is done, what we can do now is QA chain that we created here dot invoke. We can ask the question. Here I am saying what was the net loss including non-controlling interest of Uber in 2021. So here is the answer. Just to see that if it is correct or not, I have written here line 533, right? So if I go to this Uber's document, here is line 533, net loss including non-controlling interest. Answer is 122 million for 2021. So that is 122 million. Here you can see it is getting 122 million. So we have like almost 180 pages of PDF being extracted in that markdown, but it gets the right answer from there, right? And similarly, there is also the filtering things. In the previous video, I said how to do the metadata extraction and provide that into the retrieving part, right? That's what we are doing here. Here we can say filter, and we can also provide the source. Okay, go to this particular source and get the information. Here you can see there is the filter retriever, and this is where the hybrid sorts is playing the action. So if you just say go to this document and get the information, the filter retriever, pass that filter retriever here, right? And then you invoke the question. So you say how was GPT-4All Snoozy developed, and it will be going into GPT-4All, although it might go by default also to this particular PDF. If you provide the source, okay, go there, meaning that first the retrieval happens, just the retrieval happens from that GPT-4All paper, and then that information along with the prompt is being passed to the LLM to synthesize the answer, and that is being provided here. And for some reason, if you see here, I'm getting some additional information. I don't know from where. The president did not mention Michael Jackson. I don't know from where it is coming. This some issue with this inference from the Llama3, but you can see that there is also the final answer. GPT-4All Snoozy was developed using roughly the same procedures as the previous GPT-4All model. This is the right answer, but this previous final answer, it is just getting from somewhere using this Llama3. Just showing you why it is there. I don't know, because it is there. I tried many times, it is still showing. Sometimes it doesn't, sometimes it is showing. Maybe it is getting some information from this Llama3. If you use maybe other models, this might not be the issue. And one thing is, if you go to this example ENV, I have also shown this LangChain tracing from LangSmith, right? When I run all these different things, it is all being tracked. So now next part, I will show you what it is being reflected in the Qdrant Cloud vector store and in the LangSmith, right? Just to be clear here. So if I go to the vector store, so this is the vector store. If I go to the clusters, you can see there is a cluster 0 being named here, and inside here this is where I get the Qdrant URL, right? If you go to the open dashboard here, so dashboard is being open, and the rag is what I gave the collection name. So if I go inside here, you can see there are different vectors. So you can see all the different vectors and also the metadata associated with each vectors. If I click this one, you can see the file directory, file name, file type, last modified, original elements, source, and all the different information is stored as a metadata. That's when you do the vector store retrieval part, when you provide the prompt, it goes here, and the metadata, as I said you before also, we use the source, right? If we use the source, when it does the metadata extraction or the retrieval, it knows that where it needs to go, and that depends upon different vector stores. That's the difference between different vector stores, because there is Qdrant, there is Pinecone, there is other different vector stores, right? Some of them are in a way unique from another one, so they have some additional functionality. You need to choose which one to go and what each of those vector stores has in unique that might help into your application. Qdrant is quite good. You can just use this and find, okay, how does it work. And also if you go to LangSmith, when we do each and every call, it is going here and then storing the traces. If I go inside here, I'm using this unstructured Groq as the project name. If you go inside here you can see there are different questions that I asked when I did these RAG applications. All of this is being stored here. For example, this was the last question I asked, how was the Groq, right? If I go inside here, So you can see I asked this question, how was GPT for all Snoozy developed, and you can see all the information here, and it is showing you the answer. This is how you can already know from the LangSmith what is the different things, which part took what much of the time, how many tokens is being used. You can see the example here, 118 prompt tokens, 44 completion tokens, and so on. So there is many things that you can do from the LangSmith. You can watch my previous video or any document you find online to go through the LangSmith. So yeah, that's all I want to show you in this video. Now I hope you get the idea about Unstructured, how you can play around with Unstructured. The video went quite long, but I somehow consolidated all the information that we had since the past 4 videos into this last video. Just play around with it. Let me know in the comment section if you faced any issues or how you went through this particular notebook. If you are new in this channel, do subscribe. I have many educational videos in the pipeline. Yeah, thank you for watching and see you in the next video.